we are going to be chatting about simplifying radicals. And to be able to do that, we need to have a little bit of a grip on or have a chart that tells us what numbers we're looking for that are perfect squares, because that's the only way we're going to get stuff into exact form. So I will be your calculator for the first part here when we're filling in the numbers at the top. Let's see how if I can get through here without making any mistakes. I'm hoping so. I think I can handle one square. One squared, I'm good. So again, squared just means you're multiplying that number by itself. Bless you. And so let's see, 5 times 5, 6 times 6. I feel real good on the top row here. So that'll give me a second to pause once I get through it. So these numbers that we've got that we're filling in, these are going to be, I guess, our magic numbers, our perfect numbers that we're going to be looking for to break some other values down. And they can get to be larger. All right, I'm going to need all my oxygen to remember what some of these are as I get a little further. I'm going to run out of ink. That's going to be the next question. Ooh, I'm going to make it. Good job, me. All right. Survived that one. So normally we're not going to go up as high as the 20 squared. Most of the numbers we're going to deal with are going to be in that top row, okay? The 1 squared through 10 squared where we're going to get to 100. But it's always good to be prepared just in case. And so what we're going to be attempting to do is all of the examples that we have down here below are going to be non-perfect squares. Well, almost all of them are going to be non-perfect squares. And so our job, and this is going to be the biggest possible hiccup we can run into, we've got to make sure that we get the greatest or largest perfect square out every time, because sometimes we're going to have options. So I'll always tell people, start with the larger ones first and work your way back, unless you just know it off the top of your head. So for example, get one color change here. There we go. So 28. The only numbers I even need to be considering, of course, for 28 are the perfect squares that are less than that. So if you're not sure what goes in, or maybe you're like, well, I know 4 goes in, but maybe one of these other ones would. I don't know. Well, let's see. We'll go in nice, though. It's got to go in nice. If it doesn't go in nice, we can test the other ones and kind of see. We're like, okay, these are all decimals. These are not helping. But 4 does. 4 goes in perfect. So we're going to use 4 and 7. We're taking the square root of both of those. And so the square root of 4 is 2. But 7 is still acting irrationally, so it must stay in radical jail until it gets its act together. So with most of these, that's the way it's going to work. Your perfect square is going to break down, and then what's under the radical is just going to stay there if it's not a perfect square. So 54, let's see here. Just looking at these. So what is going to go into 54? And if you know, 9. Okay, let's go to 9. 9 and 6. I think that's going to be a winner. So 9 and 6. I always like to put my perfect square first because then it reminds me, oh yeah, that's the one. That's the one that breaks down and gets out of radical jail on perfect behavior. 6, not so much. Having to work on things a little bit more still. Ooh, I got a couple of doozies coming here. All right. 150, anybody? There's a lot of options here, but just let me cover up all these others that we don't need. Which one of those is going to get us into 150? 25. Again, if I'm testing it out here, I can test it out. So 25 and 6. Again, the perfect one. We can use our chart, or after you've done it for a while, you'll probably know. Get that out of there. Ooh. That's a big one. I don't even know this one off the top of my head. All right. All right, let's go to work. 720. Holy moly. Like, there are some ways to not have to do all of these, but not like with our calculator. It's going to take us too long here. If anybody's quicker than I am, I'm here for it. I'm not there yet either, though. I think I'm getting close, though. Maybe. Yeah. Okay. So here's one of those situations that I was talking about at the beginning with the greatest one. So so right here I've got 144 and 5. Let's say I was like, okay, I'm not doing all those other ones, Hardy. I'm just going to look for the first one that goes in nice. So why can't I do 4 and 180? Or why can't I do 9 and 80? Ooh, I think I might even hit one more. Or why can't I do 16 and 45? Okay, let me explain why. So the 144 and 5 is the one that we want. It's the biggest. Okay, we know that. Square root of 144 is 12, square root of 5. So here's the deal why I can't do the other ones. Let me use 16 for an example. So if that was the one I'd picked, like, all right, square root of 16 is 4. 4 square root of 45. Here's the problem. If I go look at 45 now and I start trying to divide numbers in, 9 goes in. I would have to, now I can get to the right answer, but do I really want to have to break this down again and then just multiply the numbers on the outside? I got to the same place. But sometime if you're working on something and you're looking at my answers and you're like, what the heck? Or you maybe even look and go, well, wait a minute. 12 times the, oops, hello. 12 times the square root of 5, okay? And 4 times the square root of 45. Well, Hardy, they're the same thing. So why can't I take either answer? That's the same way as saying when we're working on a quiz or something, well, I've got 4 over 8. Why can't I put that instead of 1/2? We want to simplify as much as we can, because when we have to do math with it, solve equations, we want the simplest to be able to work with. We don't want it to be hard. So if you ever have something mismatch, like I did here, always look at that radical. And if you can still take something out of it from up here, we got to do that. So that's why it's so critical to get the biggest one when you're doing these. Okay, I'm going to try and find a couple of crazy ones. And I see some ones at the bottom too. I'm not putting you through 15 more of these. The practice is going to do us good enough on some. Okay, let's do this. We're going to try out 5. Looking around a bit here. 5, 8. Ooh, I'm going to see if some of you are on it with this stuff. Okay, I think that's going to get us in good shape. Okay, number 5. Oh dear. You're going to have lots of options. I'm just going to tell you in advance. 72. What pair should I use? Ooh, nice. 36 and 2. You had lots of other options. You had 9 and 8. You had 4 and 18. But yes, 36 is the one we want to roll here. So 6. Whoop. Square root of 36 is 6. And then the other one stays in. Nice. All right, let's see what else we got here. Ooh, 200.
102.
Well, that was fast. That one was fast. 102. Square root of 100 is 10. Square root of 2, nice. What about 10? Yeah, now here's the thing. If 1 is the only option you have, now I'm not saying when I do this that 1's not a perfect square. It is. But if 1 is our perfect square with one of these, does that really do anything? Not really, because the square root of 1 is 1 times the square root of 33. I mean, I could just write it as is. I could have left this alone to begin with. So if sometime you're doing one of these and 1 is the only option, just leave it alone. It really can't get broken down any. So, not going to happen often. But it may, because it just did there. So now, these last two, here's what we're going to do on these. We're going to ignore that lead coefficient at the start. It's not disappearing permanently. But we're still just looking at the radical on these as our first order of duty here. So 48, start rolling your perfect squares, dividing them in. What's going to be our biggest one
16.
that can go into 48? 16 would be. So 16 and 3. Okay, still ignoring this for a moment. Square root of 16 is 4. Square root of 3. But that 5 is still lurking out here. And so now 5 and 4 can be reunited. They're both out of radical jail. So we just multiply them together. But we leave the radical alone. So anytime there's something working on the outside of your radical, that needs to be what we deal with first. All right, one last one here. 76. All I'll tell you is something is going to go in. It's not one like number 10. This one might take a minute.
4 and 19.
We had a couple of you at the same time. 4 and 19. Had to go all the way down to 4. So the square root of 4 is 2. Square root of 19. And again, once we've broken that down, let those coefficients reunite. 4 square root of 19. Okay. So this is going to set us up great for tomorrow when we're doing solving with this stuff, because you're going to have a good background. So here's what we're going to do with this. And then I'll put this back up here at the end. We are going to go into the radical maze here over on 3P. Now, here's what I'm going to ask though, and I'm going to even write it on here so I got proof that I asked for it. I don't want this just becoming a game of, well, I'm just going to guess, and, well, this, that other one's not broken down completely, so it's this one. I want you to actually get the practice with the breakdown that you're going. So when you're doing these, and I'll do 320 with you, just so you can kind of see what I'm looking for here. So 320, all right, let me get my handy dandy helper list out here. So let's see what we got here. Thank you. Ooh, I got lots of you. All right. So let's see, 320. Holy moly. Let's try some oops. One of you get it ahead of me. That's cool. I'm good with it, but heard he's got yeah, I think that's a winner chicken dinner. All right. I guess I should say turkey dinner. It's closer to that. So 64 and 5. So 64 and 5 would be square root of 64 is 8 square root of 5. So and then we just go to the next one that we run into. But those breakdowns are going to be important as we move ahead. So again, don't shortcut this. It is something that will be of good use to you as you go and really won't take as long as you think because you're not going to have to do every single one here as you're going along. And I do have an answer key that I will have out there. I just have to locate it in my group stuff. Oh, no, there it is. There it is. So let me